Hi everyone, thanks for watching. In this video, we're going to take a look at the factors determining an atom's charge, and once you find that charge, how do you represent it in the isotopic notation? Let's start off with atoms that have charges in general and how we talk about them. We use the word ion. The word ion confuses a lot of people, but it shouldn't, because an ion is just an atom with a negative or positive charge. That's all. The real question is, what causes these atoms to get this charge? How do you tell if it's positive or negative? The answer to that's pretty simple too. Charge is determined only by the number of protons and electrons in the atom, which makes sense because those are the only two particles with a charge at all. Neutrons are neutral, so of course they're not going to affect the charge the atom has. In a little more detail, we could say that if there are more protons than electrons, if there's more positives than negatives, the atom will be a positive. And if there's more electrons than protons, the atom will, of course, be a negative ion. So let's apply this idea to an atom where we have to determine the exact charge the atom has. Before we do that, I'd like to kind of use an analogy to make this a little bit easier. Imagine a hockey game. Imagine the Devils are playing the Flyers, and everybody knows at the end of the game, the end of any game, there's going to be a score. Let's say the score is Devils 4, Flyers 3. Well, in that scenario, everybody can very easily make the statement that the Devils win by 1 point. We all said things like this. We say things like this all the time. Well, imagine the same sort of example, but instead of teams, it's protons versus electrons, positives versus negatives. If you count the protons, and there's 4 of them, and you count the electrons, and there's 3, you could make the same statement. The protons win by 1, and that'd be an easy statement to make. The only other jump is that if the protons, the positive team, is winning by 1, you should be able to say that that atom is a +1 charge because the positive team wins by 1. In a different example, what if the score of the hockey game was 2-5? Everyone could say the Flyers win by 3. Well, if you had the same score, protons versus electrons, and there's 5 electrons, everyone could say the electrons win by 3. The only jump now is, if the negative team wins by 3, you should be able to call that atom a -3 charge atom. If we take out the sports analogy and apply this same idea to an actual atom, we can walk through one of those too. I could give you this picture here and ask you to determine the charge of the atom. You should start taking score. Positive team versus negative team. Positive team has a score of 6. If you count the electrons in the rings, you'd see the negative team has a score of 8, which means the negative team, the electrons win by 2, so you should be able to say that this atom has a charge of -2 and is now called an ion. There is one more thing we have to mention in this video, and that is, once you find the charge, how do you represent it on the isotopic notation to give a full picture of what an atom is like? It's a pretty simple answer. When you know the charge, you just put it in the upper right-hand corner. So if you find that it's +1, you fill in +1. If it's -3, you fill in -3, and so on. We should also point out that if the symbol is written without a charge, which is all the symbols we've done up to this point have been this way, then we actually assume that the atom is neutral. And if it's neutral, that means it has no charge. That's why you didn't put one, which means the protons and electrons are equal. Let's practice applying this with 2 different isotopic notations and see if we can use that to figure out the proton versus electron count inside these atoms. The easiest place to always start, of course, is the protons, because the atomic number just gives you that amount straight away. Both of these atoms are magnesium, so both have an atomic number of 12, so both have 12 protons. The electrons take a little more thought. For that, you have to consider the charge. This first symbol has no charge, which means it's neutral. And to be neutral, the positive team and negative team are tied. So if there's 12 positives, there's 12 negatives to balance them out. This one's a little bit harder because it does have a charge. The charge is +2. Remember what we said about a charge of +2. That means the positive team is winning by 2. So the protons are winning by 2, which means the electron count has to be 10. That actually concludes our video on atoms with charges. Here's a brief recap to follow.